If you want to assign a variable of one type to the variable of another type, then the destination type must be larger than the source type. That is, if int I equals 10, then this variable I can be easily assigned to any long or float or double variable. But the reverse would be incorrect. That is, if double j equals 10 and int j equals I, that would be incorrect. That is, we get an error that says cannot convert from double to int. So if you follow this sequence from left to right, then a variable can be easily assigned to another variable. That is, a byte variable can be easily assigned to any of these variables and sort to any of these other. But you can't assign an int variable to a sort variable. If you follow this sequence from left to right, then you are doing a widening conversion. You can see here all these data types have their own size, but as I told earlier, the destination type must be larger than the source type. But you can easily assign a long variable to a float variable, even though a long data type has bigger size than float. uh, this happens because Java uses widening conversion, and since a float variable can contain decimal places as well compared to the long variable, the widening conversion makes sense. But in the Java language specification, they have mentioned that there may be some loss of precision. That is, the result may lose some least significant bits of the value while converting a variable or assigning a variable to another variable of different type. That is, when we assign a long variable to a float variable, the resulting floating point value will be a correctly rounded version of the long value. But there is a danger that we may lose some information. And if you have a mathematical expression involving different types of these data types, um, then the result will be the most suitable data type which follows this very sequence. Suppose in a mathematical expression you had variables of type int, sort, long, and float, then the result will be a float. In that mathematical expression, if you are assigning that to a value, then the variable must be a floating point number, and if it contains a double, then the result will be a double, and you need to assign that expression to a double variable. So that was all about Java's automatic conversions when you follow the winding conversion sequence. But if you follow this sequence from right to left, then it would be a narrowing conversion, and we would have to do something different. So we have this example that in which an int variable was assigned to a double variable and it was an error, but we can do this in a way that Java provides us. So to create a conversion between two incompatible types, we must use cast. So before moving on to casting, we must firstly learn how Java's assignment works. Suppose we have a variable var of data type simply type and is assigned to an expression a plus b plus c plus 34.67. Then this assignment can only work if the data type of the variables and any values in this expression is equal to the data type of the variable var, in this case type, or if the data types of the variables used here uh, is either smaller in size than this type, that is if they follow the widening conversion. But If the data types condition is not fulfilled, then as always error will occur, and we must convert the data type of those variables which are larger in size. So if the data type of b is larger than the data type of var, then we must use casting. So to do so, we keep empty parenthesis uh, before b, and inside here we mention the required data type, that is type. So what it does is it will convert the data type of b to the data type of var, that is this type. Suppose if it was long, and we need to keep here long to convert the data type of b to long, and only then it will work. So using this process we can convert all the incompatible types to make it compatible with this with the data type of this var, and this expression can work. So we had this statement right here that said int j equals this double variable I. So for this expression to work, we can convert the data type of this variable I by keeping those empty parentheses before I and converting it to int. Then the error will go and things will work correctly. So now you know how casting works. And you also need to remember that we use casting when we follow the narrowing conversion, that is when we follow the sequence from right to left. But if we are following the sequence from left to right, no casting is required. So let me now talk about one really important thing in any programming language, that is operator precedence. This simply refers to the process by which priority of an operator is decided. Not following the operator precedence may result in several errors. So the best practice, rather than memorizing the operator precedence list, is using parentheses at suitable places. Parenthesis is at the highest priority, and it will alter any precedence of an operator. Suppose we want to print sum of 10 and 20, and we do this by printing out them directly here. That is sum of 10 and 20 is 10 plus 20, and let's print this. But we simply get the result in which these two data are joined. So we didn't want that. So what happened here is this is a string data, and it didn't give priority to the addition operator. Rather, it used this plus sign as concatenation operator that is used for joining two datas. So we wanted the sum of 10 and 20 to be printed. So what we could do here is we could surround them with the parentheses, and now it would firstly add these two values and then concatenate it with this string. Then we would get sum of 10 and 20 is 30. So whenever you encounter any situation in which operators trouble you, just use parentheses whenever required. So with this we have concluded this tutorial, and now we will move on to selection statements.